Welcome back, guys. Dr. Nanette K. Hartley again. Then we are back for our last virtual lab introduction. This is for colligative properties. Now, I'm going to be honest, colligative properties is one of my favorite topics in general chemistry. I find this absolutely fascinating, and it was the topic that I was given when I was hired here. So I love talking about this. Now, our purpose in doing the colligative properties is to experimentally observe the effect of ions in solution on a freezing point of a solution, which is a colligative property. Important background on that. Colligative properties are dependent only on the amount of ions, not what those ions are. And that's very unusual. Most properties that we're looking at have everything to do with what that thing is, and not just on how many of them there are. That's a very strange thing for us to be talking about. And the equation we need to use to look at this is delta TF is equal to IKFM, where delta TF is the change in the freezing point, I is the Van Hoff factor, generally the number of ions that something dissolves into in a solution, usually water. Kf is the freezing point depression constant of the solvent in units of degrees C times kilogram per mole. And M is the molality of the solution, units of moles of solution per kilogram of solution, moles of solute per kilogram of solution. I apologize. Now, Alex will tell you that molality is an antiquated unit, and we typically refer to it as moles of solute per kilogram of solution. I don't think it's antiquated at all, but that's because I'm old. So all KF values are tabulated, so you can look them up or they're given to you. This is not something you need to know on your own. This is something that Alex will tell you or will be given to you on a test. So that's something that you're responsible for. So that is important for you to understand. Now, that's our background. That's the important part of this, okay? One of the things that you need to understand is that if we're talking about something that doesn't dissociate, is not ionic, then our I is going to be 1 because it doesn't come apart. If it is ionic, we need to know how many ions it becomes. So something like sodium chloride that becomes 1 cation and 1 anion, the sodium cation and the chlorine anion is going to have an I of 2. Okay, so it depends on how many ions you get out of it, what that I is going to be. The more ions you get, the bigger this effect will be. And so that's an important part of this. Okay, so that's all of our information about that in our intro that we needed to talk about. So I'm going to close this out, and I'm going to take us in, and we're going to take a look at this freezing point depression lab. I'm going to go ahead and open this. And again, just like we always do, I'm going to start this. We'll get to some of our pain points, and there are a few pain points with this lab, some things that we need to talk about. So things that you will need to be able to look at when we're doing this. Now, remember, all of this information is available to you. You should be making a lab notebook with this information so that you can take the post-lab quizzes with that information. It is something you're expected to do. The freezing point depression constant for Kf for water is 1.86 degrees C per molal. Okay, so that's the constant that we have for that. Here's our equation, some stuff like that, and we'll be able to solve for some things using a plot of this data. So let's go to our simulation, and I'm going to let you solve for this. Of course, I always do that. So I'll pause here. Now, there are an awful lot of things you are asked to calculate in each of the runs for this particular experiment. There's a lot of stuff here, and some of it you're asked to directly measure, and some of it you're asked to calculate. So for any of these things that you're asked to calculate, you have to look here for a lot of that information. So again, you have this table of information that they've given you that's analogous to your own data. So write down your data, do calculations in a very similar fashion. Now, this doesn't cover everything. So these are only the things that they think you can't figure out on your own. There are some pieces of this data that you won't be able to get from this. So this tells you how to calculate the moles of potassium bromide, which is similar to our magnesium chloride, the mass of water in the final solution. It gives you the mass of the ice melted and the mass of the water in both grams and kilograms. What it's not going to tell you is things like the mass of the ice added, which you'll have to figure out on your own. The mass of the ice remaining after decanting, that's something you'll have to figure out on your own. Some things, mass of the melted ice, some things like that. So you will have to figure out those calculations. You have enough information to do so. What you need to think about is what are they actually asking you to calculate? So if you want to know the mass of the ice added, for instance, then you need to figure out where is it that you only have ice. So if you want to know the ice by itself, then you have here the mass of the calorimeter plus the solution plus the ice. And over here you have the mass of the calorimeter plus the solution. So if I take this and I subtract this, the only thing that's left is the ice. So think about the numbers that you have and think about what happens if I subtract this from this. What's left if I do that? So that's what you need to think about when you're doing these calculations, is what is left. So treat this just like you would anything else. Those names are your variables, and make sure that you're accounting for what you need to look for. Make sure you've gotten rid of anything that you don't want to leave what you do. Okay, so you should have everything you need to be able to do this. Now you'll go through the data collection for each of these 3 runs, and then you'll be asked to do some plotting of data to get your Van Hoff factor. And when they talk about that, they'll walk you through how to do that Van Hoff factor here. So once you've plotted your data, they will walk you through how to get that I by getting the slope of that line divided by the KF. And you know what KF is. So you'll be able to solve for that without too much of an issue. Remember to follow the data. Make sure you calculate everything the way you're supposed to. And if you get to a point where you've calculated something and it turns red, pay attention to what it tells you in terms of the error. Is it a significant digits error? In which case you need to look at how many sig figs you have. So some of these have 4 numbers, some of these only have 3 numbers. So you've got to round to 3 or 4 decimal places depending on what you're working with. And some of these things is going to say, what's wrong with your calculation? And then you need to look at, how did I do that calculation? Did I do it correctly or incorrectly? So those are your pain points there. If you have any questions about this, contact your instructor, okay? They'll ask you what the freezing point depression is, and that's based on the number that you get here. But don't forget that you have to correct it based on what the freezing point of the DI water was. So you have to take this initial minus the final to get that freezing point depression. So you'll take this one minus this one to find out what that delta T is. Okay? I think that's everything. So I'm going to stop sharing, and I hope that you guys got some stuff out of that. Hopefully this will be not too bad for you, and I will see you on the flip side. Thanks, guys.